okay. So we've talked about the basics, those things that's labeled basic truth tables. I'm going to take for granted that you have that handout I posted in Moodle handy as you look at these things. Yeah, since everything's open note at this stage, that should be okay. So I wanted to take a look at some more examples of this stuff in action, a little more involved than just two simple statements, one connective kind of thing. So you'll see I've got this compound statement up here. So we have the conjunction of P and not Q. Then we have that linked via a disjunction with another negation. So we're going to try to work through everything that's going on in here. If you remember my process from last time, I said, write a column for each simple statement. We've got that taken care of. So yeah, that should look familiar. It's the same thing that was sitting on the left side of most of the basic truth tables. And going from here, I'm going to take things in very, very small steps. That's really the best way to go with this sort of thing. So generally speaking, if I see I need to negate a statement, it gets its own column. If, from there, I kind of work with, bit by bit, standard order of operations, deal with parentheses kind of stuff. So taking a look at this guy, we see we've got the negation of P and the negation of Q. It can be tempting just to try to remember, well, that's an opposite. I'll remember what's going on. I really do recommend that until you've got a lot of practice with this stuff, it's probably in your best interest to go ahead, take the extra time, write out a column for each of these negations. So got those guys sketched in. Now, individually, it's not going to be too overwhelming, hopefully. The idea is I now focus on this P column to try to figure out what's going on in here, and I need to flip-flop the truth values. Any T here would become an F for my negation, and then vice versa, and F becomes a T. So that's what a column in my truth table for the negation of P is going to look like. Same thing is going to happen for the negation of Q. I just focus on this column, and I flippity-flop all of my truth and false values. So I have false, true, false, true. Okay, we've made some progress. That sometimes is good just to have something on the paper in front of you. Thinking on paper is some of the best advice I've ever gotten from a math teacher. So now we need to deal with sort of the paired connectives. I called them binary before. I mean, same thing. So that's not a question on the test. So generally speaking, if we've got stuff in parentheses, we sort of need to work our way, from the inside out. So I need to deal with this guy. So I'm going to have P and not Q. Now, I technically need two columns at once. This is the most I should ever need to deal with at a time. And when I do something like this, I normally like to mark the columns I'm looking at so I can kind of keep things, straight in my head. So I'll draw like a little arrow right here above the columns that I'm focused on at the moment. And hopefully you'll remember from the last time, or if not, you've got the handout in front of you. Like I said, taking that for granted. I've got a conjunction, right? Conjunctions are true when both pieces are true. Otherwise, the conjunction is going to work out to be false. So if I look here, I have a true statement and a false statement. That is going to be false. So F. True and true. That one is a true. False and a false. It's a false. I'm going to stop trying to look back over my shoulder. False and true. Again, they both have to be true. That's not the case. So false. We're almost done now. Because now all that's left is to take this guy in the parentheses and hook him up with the negation of P via a disjunction. So now I don't need either of you guys, because I've used them before. Again, if you do this the way I'm suggesting, you never need to look at more than two columns at once. We need him. We'll mark that guy. And we need the negation of P. So mark that. So from here, now we take a look at this. A disjunction is true if we have at least one true. Do we have at least one true here? Not so much. That's a false. Do we have at least one true here? We do in point of fact. True or false. Again, we have at least one true. True or false. again, at least one true. So that's where the truth table for this guy is going to draw to a close. So it turns out the only way this wacky compound statement ends up being false is if both P and Q had been true in the first place. So this isn't driven by any like real world type example in this instance. I was just using it sort of to get a point across. But that way we've sort of seen how to use these various truth tables in the context of some examples. All right. I've got one more I want to take a look at in this video, and then we're going to up the degree of difficulty a bit. We throw a half pike into the dive. I'm not into diving. I don't know if I said that right. Bear with me. All right. So I'm going to try to preserve the layout of the table as much as I can. It's not going to work 100%. Yeah, that's going to go. But anyway, I can keep my initial stuff intact anyway. I'll draw that line over. All right. So the guy I want to take a look at, we've dealt with a conjunction, a negation, and a disjunction at this point. Let's take a look at something going on with the conditional. So this one isn't quite as intense as the one from before. We'll go pretty gently. So we have P implies not Q. So you may remember this is what we talked about before, like that symbolic translation of a sentence like no P or Q. So let's take a look at under what circumstances this compound statement turns out to be true or false. So, like I said before, give a negation its own column. We see a negation of Q here. So he gets his own column. Again, it's not intense. I just need to take all of the values here underneath Q and flippity-flop them. But I think it works better to work with it on its own. Now, at this point, we only have one more connected to deal with. We've got to hook this thing up to P with a conditional arrow. So P implies not Q, right? So now, when it comes to a conditional, we talked about this in the last video. Remember, the order in which things are arranged around this conditional arrow makes a difference, unlike conjunctions or disjunctions. So instead of just marking the columns I'm paying attention to with an arrow, I normally do like a left-right thing. Some folks would like number them 1 and 2. I'm just going to do L for the left side of the conditional, then a capital R for right side. If you have a statement that's using R, maybe the 1, 2 thing is better. But anyway, so we have left, we have right. Remember, if we have true implies false, the conditional works out to be false. Otherwise, it's a true statement. Here we have true implies false. It's almost like I did that on purpose. True implies false. We just said based on our conditional truth table, looking at that TF and then what's on the other side line, it works out to be false. True implies true, and again, it kind of may help if you do this where you put your finger down individually on stuff like I just did. True implies true is true. False implies false. Looking at the truth table for the conditional, it is in fact a true statement. False implies true. Your roommate got you a sandwich even though you gave him no money. This thing is still a true statement. So, weirdly enough, it works out exactly like the last one, I think. Huh. Interesting. I promise I didn't plan that, it just happened. So there's a couple of examples of how you can sort of walk through the steps of this operation. Again, I really do recommend doing this like one bit at a time. Don't try to bite off, an awful lot at once. That's usually where I see students go astray, is they're like, oh, I can handle dealing with a negation alongside this conjunction, or, something like that. Don't do it. All right, so I do want to, like I said, ramp this up a bit. We'll take a look at some statements next time where we have more than just a pair of simple statements built in. So buckle up.